by first introducing the applications of injection molding and the process of it. As with many manufacturing processes, there are bound to be some issues such as short and warpage. Hence, Mr. Steven will also address some of the common defects. In the last part of the presentation, he will also introduce computed engineering, CAE, to us and what sort of advantages it has. So be sure to pay attention. Before we start, let me explain how you can talk to us during the presentation. If you have any questions during the presentation, you can type them in the Q&A section in the right side of the chat box icon. Do note that this function does not work in mobile version of Google Meet. So yeah, we will have a Q&A session in the last half an hour of this 2-hour webinar. So now everyone, please join me in welcoming Mr. Steven Lin.
Thank you for your opening, Victor. It's very clear, and thanks for introduction. And I also want to express my appreciation to Dr. Lee and Dr. Ong, because without them, their hard working, we won't have this chance to conduct this online webinar. And today, just like Victor's introduction, there's 4 main topics I would like to explain and I want to introduce to you. There are the application of injection molding, and what's the manufacture cycle of the injection molding, and during the manufacture, how we will meet the common defect and how to solve it, and what's the main reason that this defect happen, something like that. And in the end, I will also emphasize what's our CAE for, what's our feature and what's our function to help you to solve the problem. Okay, so let's get started. And right now I will share my screen. Okay. Okay, everyone, can you see my screen now?
Yes.
Okay. So this is our outline, and just as I mentioned, the 4 topics I will mention before that, I will talk about our history. Okay, what's the CAE? And because before we talk about the CAE, and I also want to give you some brief idea. It's like can you imagine the first time when people want to operate like an aircraft, and at that time we don't know how to operate it, so we just create the similar one, 100% similar of the real aircraft. So before we fly to the sky, we can just operate in that by the simulation way. So it's like a digital twin. Basically, it is almost the same thing, but we did not do it in the real way. We just simulate it. So after we get familiar with this, and when we want to do it in the real situation, we already know how to do it. So the role of CAE is like that. So that's why I say that this is like a digital twin. And the feature of our CAE also can predict defects and improve the manufacture process. Okay, so about our history, our CEO, actually, he's a professor in a well-known university in Taiwan. So his major subject is chemical, and which means our software is based on a very powerful academic background, because he do the research for many years and start to do this, start to the career of the Model 3D. And before he set up our company, because he set up in 1995, and before he set up, he already had this kind of idea in 1983, and he already has a lab in the campus. The highest amount of his students is over 100 in his lab. So at that time, he already have the ability to develop the software. And after the software getting mature, and he started the career of the Model 3D. So the idea of the injection molding, this kind of idea start from 1983, and he found our company in 1995. And the purpose of the software is helping the user to save time to do the try and error. Because in the past, we have to do a try and error. We have the idea, the engineer have the idea to design the mold and design the part. And they have to try and error many times to meet their criteria. So actually this will waste a lot of the material because you need to do a try and error many times and also waste the time. So we use this software, just that I mentioned earlier, it's like a digital twin. We simulate it, so we will know what will happen in a real situation. So it can help you to save time. And because you don't need to do it in a real way, and there's also no limitation how many times you can do it. And if you save time, you can launch your product before your competitor. And before your competitors, then you can also get more market share in this market. So the advantage of this product is that. So this is our purpose to create this kind of product. So we also play a pioneering role to build the possibility of the T0 mass production. What's the T0? The meaning of T0? It means we don't need to do even one more time try and error. We can just create a perfect mold. Then we do not need do any try and error. Then just manufacture it directly. This is the concept of T0, and this is also now what we are focused on. Okay, so let's move to the next slide. Okay. Our product line, as you can see in the bottom, there are software, solution, and service. Right now, you already know our main product is the software. We help you to predict what's the defects, and we can simulate what will happen in a real situation. So our main product is software, but not only a software, we also provide a solution, because sometimes the customer, they want to use the compound material, and the compound material is like a customized material. So we don't know what will happen if during the manufacture. So we also cooperate with our customer to develop the solutions to help them to solve their issue or something. And also you can see the service here. Because why we have the service, just that I mentioned the material service, because we do some material testing service to enhance the accuracy. So those three is our main product line now. And you can see we already have this idea, like I mentioned, 1983, and we connect the global market in 2001. So we connect to global market in 2001. So now we all of the region, we all have for example, in Malaysia, we have the 2 qualified or 3 qualified reseller, the sales partner there. And also in China, we have our direct office. So most of region, we already have the reseller to sell our service in a local place. And over time, we become more mature, and our software always keep improving. So we develop every year. We always develop a new version, and even increase the completable ability to a variety of the CAE software, because okay, as you can see here, Simatron and Siemens, something like that, because we want to enhance our compatible ability. So you can also experience our software in a different interface. So nowadays we have the service like I mentioned, the software solution service and non-stop the molding innovation till now. Okay, so what's our main product is basically the name of our main product is called Model 3D. So Model 3D is the world-leading provider of the plastic simulation solutions. And right now we still focus on to increase our material data bank, because later I will explain what's the process of the injection molding. We are not only have to care about the part design and more design. We also have to think about what's the material that we will use, because the material also is the very main reason that we want when we manufacture. So we also need to consider this material is like a thermoset or thermoplastic, and even some material that with the fiber inside. So all of that. For example, right now we have to still increase our material data bank, because just like I mentioned, the material still keep increasing. Different material, customized material, compound material, the amount of material is keep increasing now. So we always increase the bank of the material till now. And we also have the cloud storage, and the cloud storage because in the past we have to rely on the experience of our engineer, and if we can upload our data to cloud storage, then it's also easier to make us to manage our data. So, and the second, we will always like play the rule. We can help user to save time and the cost. Okay. And what we do, we bring the more efficient way to optimize your design with environmental, the sustainability instead of the traditional try and error method. And second, because like I mentioned, time is money. So you need to launch your product before your competitor. And we always build a long-term collaboration to grow up with our customer together. Then, so if you can see this illustration, and at first we do the part and more design. Then we use the CAE verification and do it again and again, repeat it till it meets our criteria. Then we start to do a tool making and do the production in the end. So so this is our history. Then let's move to the application of injection molding. In second part, sorry. Okay. In second part, let me introduce the application of injection molding. What's the first thing coming to your mind when you hear this, the injection molding? Actually, as you can see here, there are a lot of products that we will use in our daily life. They manufactured by the injection molding. And the polymer product, there are three manufacturer ways to manufacture the polymer product, like injection molding, extraction molding, blow molding. But today I would like to focus on the injection molding. As you can see, the major process in polymer processing in this pie chart, the injection molding still occupy the biggest share in this pie chart. It's around 40%, because there's some advantage in injection molding. Because the injection molding, then as you can see, it's be capable of the producing parts with a complex geometry in one production step. As long as you can have the perfect design for your mold and part, then you can just do it for the mass production in a short time. So this is the advantage of the injection molding. And injection molding also has like an excellent dimensional tolerance and requires almost no finishing or assembling operation. So that's why most of the factory, they would like to choose the injection molding, because the injection molding can save their cost. And the wide range of the production capacity and wide range of the plastic materials can be applied. The thermoset plastic, plastic material, and also like a fiber context. For example, nowadays the automotive industry, they would like to enhance the strength of the bumper, so they will use some fibers inside, including all of these things. So right now we still rely on the injection molding, very heavy like that. Okay, and in this slide you can see what kind of product they manufacture by injection molding. There's like a computer, automobile, the dashboard here, and the household, the printer, and telecom. So some of the mobile phones right now still manufactured by injection molding, and cosmetics products, and even optical products. The camera, because we need to make sure it's very transparent. So this kind of the product right now, we use the injection molding to manufacture. Even the semiconductor, because the compression molding or transfer molding, we also use the concept is very similar to the injection molding. Yes. Okay, let's move to this slide. And like I mentioned, the optical, because the integrated technology solutions, we need to consider about is transparent enough, and the standard injection molding solutions and lightweight demand market here, because for automotive there is a lightweight demand, can save the consumption of the energy. Then innovative molding process, the innovating of IC package is because they improve their generations, it change very fast. So that's why we always cooperate with the IC package customers, like for long-term collaboration. And efficient heat and cool control, because during the manufacture of injection molding, you need to focus on how to adjust not only the temperature but the pressure, because we have to melt our plastic before it inject to our mold. So we have to control the temperature very carefully, and also the composite process. So till now, you will know there are variety industry. Right now, they rely on the injection molding, and there are also a lot of products. And if you especially want to do the mass production, is efficient. The most efficient way to manufacture products. Okay, so this is our customer, and in your left-hand side, you can see that there are a lot of well-known automotive brand here. There are Ford and Toyota, something like that, and high technology company like Canon, Sony, and even like I mentioned earlier, the IC packaging. They want to do the simulation of the underfield, the micron, when they want to manufacture like the chips or something. They also have to use our software to simulate what will happen in a real situation. So like all of that, I think you already know what they manufacture for. So in this part, we talk about what's the injection molding can apply for the products and apply for what kind of industry. Okay, so let's move to the next topic. The next topic is the process of injection molding. Okay, the injection molding process, because you can take a reference from this illustration. Basically, there are three main units here. The first one is contract unit, and the mold unit, and clamping unit. The contract unit you can imagine is like the brain of a human being. You need to know how to set the parameter, because not only the temperature but also the pressure will affect the result of the part. So you need to do the setting first. We use the contract unit to do the setting. Then the mold unit, before we manufacture it, you need to have the good design for your mold. So the mold should be like can be inject easily. Otherwise, the appearance of your product maybe will be destroyed or something. So you have the good design of your mold unit and also the clamping unit, because when you want to inject the milled plastic into the cavity, then you have to make sure the clamping force is already good enough. Otherwise, it will also cause some defects. So as you can see here, we have to melt the plastic patty here and then fitting in the fit whooper. Then you can see here is the heating element. So when the plastic, they will start from here, the screw, and pass through the runner till cavity. So we have to make sure it's already milled completely. Otherwise, it will also cause the defects, because if it not melt completely, then we use the screw to move forward. Then when the screw move forward, then the milled plastic will be pushed into the runner and cavity. So we also have to consider what's the length, what's the distance of the screw move forward. Then after it move forward, then inject the milled plastic into the cavity and runner. Then we will move to the cooling stage, because we have to make sure it's already cooled down perfectly. Then we can inject it. Otherwise, it will have the shrinkage or warpage. So we also have to consider about what's the cooling time. So basically, this the injection molding. What's the process of the injection molding? You can also take a reference like this slides. So the first slice, we mill the plastic pellets inside, and make sure that already become milled. Then we start to fill in. The second one is we fill in the milled plastic into the mold. Then we packing it and make sure it already cooled down. We have to do the injection. So we just do this repeat and repeat to do the a mass production. So till now, this technology is still the most efficient way to manufacture the products, because they can to ensure the quality is almost the same, because our mold is already there, and the mold is made by the metal, so the strength compared with the milled plastic is still strong enough. Then it means it can be very durable. So most of the time right now we still have to rely on this kind of technology very often. Okay, so like I mentioned, actually the injection molding, this is a very complicated process. As you can see, at first you need to select the material. What kind of material that you want to use? The thermoset, ceroplastic, and even like I mentioned, the plastic with fiber inside. So at first you need to select the material, and also you have to consider about some material is not, when you melt it, it's not very easy to flow. So if it's not very easy to flow, you also have to consider about like a short sharp something. So at first you need to select the material. And the second, you need to decide what kind of machine, because if the machine of the camping floor is not enough, it will also cause some issue here. So we have to select the machine, and the process setting that I mentioned, the parameter will also affect the result of your end products. So you have to do the parameter, like how long for the cooling time, because if you set it for too long, it will also affect your working efficiency. So about this part, you have to think about it, and also have to consider before you manufacture it. And the mold design and product design, two of these things, I think the most engineers, they also have to think about it before the manufacturer. So those four things you need to think, and every factors of this will affect the quality of your product. So actually, the way is still very complicated, and in the past, we always use the try and error till it become the perfect product. So it will take a longer time. If compared with someone that use the software to predict. Okay. So right now I want to introduce some of the common defects in the manufacture. So there are 6 common problems that we will meet during the manufacture. There are short shot, and burning, and wear line, and seam mark, wear patch, and flash. Okay, as you can see these slides, the definition of short shot is that you melt your melt plastic cannot fill full the cavity, like you can see here, because it cannot fill full the cavity. So when you inject it, then of course this will become the issue. It's like a short shot. So this actually is a very serious problem for the appearance, and is caused by the underfilling of the mold cavity. So what caused this happen? Because sometimes you choose the material is not easy to flow, so it cannot reach the corner of the cavity. So in the end, it cannot fill full. And another reason is like because we have the venting in our mold. So if the air cannot escape from the mold, from your mold, from the cavity, it will also make the melt plastic cannot fill full the cavity. And another reason is like if your part is too, you design the part is too thin, because it's too thin is can you imagine if when a melt plastic, when it froze, then because that part, the position is too thin, then it will become solid very easier, and when it becomes solid, then it will cannot flow anymore. So that kind of reason will also cause the short shot. Anything that will affect the liquid to flow smoothly, then this kind of thing will cause a short shot. Okay. And the next one is the burning, the burn mark. you can see here's the some black in the corner. And what's the cause the burn marks? It is actually the major cause is the air trap inside the mold cavity, because just like I said, you have to consider about the venting, that your air can escape from your mold. Otherwise, if the air in the corner, and because it affected by the pressure, so if the air inside the mold cavity is compressed, being compressed, then the temperature will increase rapidly in a very short time. So at that time, it will have the burn mark here. So this is also a very big problem when you want to manufacture products, because this will affect the appearance very serious. So no customer can accept this kind of issue. So you also have to think about how to make the air can escape from your cavity easier. So this is the burn mark. Okay, then let's move to the weld line. As you can see, here's a line here, and if there are two or more plastic flow from, because when you melt your plastic and inject into the cavity, and because some product is not only have the one like a runner or a spool, they have the more than two runners there. So when they inject, of course they will not only have one flow fronts, they will have the multiple flow fronts. And when the multiple flow front meet together, then during the injection molding, then this incomplete fusion can occur as the mill front is lower temperature and harden first. So when it becomes solid, and it will have the weld line there. So how to design the gate? How to put the gate in the, because some product is like a bumper. They cannot just rely on one gate. They have to use a lot of gate to manufacture product, to inject the milled plastic. And if you set up too many gates there, then when the flow front meet together, then it will cause the weld line. So you can see that it will always happen. Here's the holes and the merging boundary of the finishing procedures. So it was open around the that I mentioned. It will happen around the hose or the spool. And how to avoid to generate this kind of weld line? So you need to think about your thickness changes, because if you have the significant thickness change or multiple spools in the mold, then it will easier happen this weld line. And I think this weld line is not only affect the appearance of the product, but sometimes if the weld line, the angle is like very straight, then it will also affect the structure of the products. For example, it will easy to broken or something. So we also have to avoid this kind of issue happen. This is the weld line. Okay, let's move to the sink mark. The sink mark, actually because the temperature between the inner, you can see the inner and the surface. If the temperature between two of these sides they cool down at a different time, then the mold will cool and harden more faster than the inner here. Then the later the inner part start to cool down, they will pour up the surface. So this will cause the sink mark, because the temperature between the surface and the inner part, the time that they take to cool down is different. So the surface already cooled down, but at that time the inner part they haven't cooled down yet, so they will pull it down. Then it will cause some appearance issue here, because as we know when the products, if we hit it, then the volume will increase, and after it cool down, it will have the friction or shrinkage. So how to avoid this kind of issue, this kind of defects? We have to think about how to make the time that the surface and the inner part they can cool down at the same time. And the voice here, because this is also happen if the surface, the strength of the surface is good enough, then the inner part cannot pull it down. So at that time, they will pull some parts. Maybe the strength is not good enough. So this will cause the voice here. So this is the same mark. So to solve this problem, we can also think about how to design our rib here, because if we made the temperature of everywhere is more even, then we can solve this problem. Okay, let's move to a wall patch. And the wall patch, they denotes the distortion of the deformation, because the wall patch is like a deformation. So if the defect types in most commonly seen in the injection mold products, because if after you inject it, it will shrinkage. The shrinkage will always happen, and if some part is more thick, then the shrinkage level will be different. For example, if you can see this part, the thickness of this position, and because the time it takes to cool down is totally different compared with this thin part. So if the shrinkage level is different, then they will pour each other. Then when you pour each other, then we'll have the wall patch, this kind of issue. And what will also affect the wall patch, like if we put a fiber, and if the fiber have the different orientation, then this kind of things will also affect the wall patch. So after you see the result of the wall patch, sometimes it will look like the wall patch is like upper, from the upper side it's like a smile, the smile face. So sometimes they're like a crying face. So it's different. So we need to make it every part they can shrinkage almost at the same time. If they take a different time to cool down, then for each other, then it will cause the wall patch. So this kind of defects, especially for some product they want to assembling with each other, then of course this cannot meet the criteria because it cannot be assembling. So this is the wall patch. So all of this is the common defects. Sorry, and there's one more that is like a flash. You can see the flash. We have do you remember we have the clamping unit? Because when we inject the milled plastic into our cavity, if the clamping force is not good enough, then it will cause the milled plastic they will come out. So after you inject the product, it will become the flash. So we need to consider the clamping force is good enough. Otherwise, it will cause the flash issue. Okay. So let's move to the rule of the CAE. And the rule of CAE, as you can see in these slides, because the develop and the application of the new material, we already built our data bank in our software. So some of the product, even we cannot predict 100% because it's like a new material, but their kinetics is similar. So we still can predict what will happen. And nowadays, most of the technology company, they develop their own material, like a compound material. So we can help them to do the curve fitting or something, and after they develop a new material. Precision and quality requirements and manpower training, because in the past the senior have to teach the junior how to upgrade the software, and after the manpower, if they face some shortage of manpower, is sometimes they will face the obstacle to operate their machine, because they have to rely on the experience from the previous engineer. So if we build up this kind of software, we also have the cloud service. You can upload every data to the cloud. Then the next engineer, the next generation of the engineer, they want to use our software, they can gather the data from the cloud easier. So this is the manpower training. And the innovation in molding process, we have a lot of experience here, because we have a lot of customers from different industry. Then when our potential customer, they want to experience our software, we still can give them some technical support and some suggestion to improve their manufacturing process. And like I said, there are two things before we do the manufacture: not only the mold design and the part design. So about the part design is similar to our product design. We need to think about there is no significant thickness changes. Otherwise, it will cause like a weld line, something like that. So how to design the product is also very important, because if you design a product is like some position is too thin, it will also cause the social issue. So we need to think about this. And like I say, the CAE was the most advantage of CAE, because you need to do the try and error in the real situation. You can do it in a simulation way, so it can save your time, also save the cost do not need to waste your material, because when you do the try and error, it will sometimes, especially your material is like a thermoset, and you cannot just reuse it. So this also our most advantage. We can help you to save time and save the cost. And just like I mentioned earlier, the save time is also can enhance your working efficiency. So this is the injection molding that we will meet the challenges. Then in this slides, you can see at first the engineer have their concept in their brain. They need to think about what kind of product they want to manufacture. So they start to do the part and more design. And you can see if after the part design, more design, they start to do tooling. After tooling, they will start to do a trial. So if they found the result is not good, then they need to go back to the part design and more design to do it again. And as we know now, there's not only these two things will affect result, but they also have to maybe change the barometer of the cooling time, and change the barometer for the length of the screw move forward, because if the distance of the screw move forward is too, and it will also affect the result of the products. So in the past, this will waste the cost, time, the material and energy. And right now we use our software, and so you can do it online. You can do it on the software. So no matter how many times you do it, it won't waste your cost. So from some experience from our customer that use our software to save the cost is always happen always happen right now. So this is our advantage here. So you can compare the right hand side and the left hand side. We use the CAE to replace the real try and error. So just that I mentioned in the beginning, at first we don't know how to operate our machine, but we still can design the 100% the same situation as the same as the reality. We call it like a digital. It's a digital. So before the pilot, they don't know how to drive the aircraft. They still can experience how to drive it. Till they really want to drive it, they already get familiar with how to use it, how to operate it. So we use this CAE to replace the traditional way. Okay. So the optimization is the you can see the problem, relation, cost, and solution. Okay. And the CAE position, because I think most of you already get quite familiar with the like a CAD/CAM. And in the past, we only have CAD/CAM here. So you can see our position is in the middle of the CAD/CAM because we use the CAD to maybe draw a line or to do the part design. Then we use, then later we use the the CAM to do some tooling. So before the CAM, we use our software to make sure the every step of the manufacturing is already good enough. Then we can start to manufacture it. So it's like we do the part more design here. Is we use a CAD to do this. So in our software, we just like I mentioned, we just always increase the compatible ability with the different software. So you still can use it in different software. We just try to enhance ability of the our ability to let you to use in different interface. So you can see the part more design here. We use a CAE verification and repeat and repeat till it meet our demands. Then we can start to do a tool making and do the production in the end. So basically this is our position here. And you can also take a reference by this slides. And we have the data input. So you can see the model 3D here. We need to build up the runner at first, then do the FPCW, which is filling, packing, cooling work patch. We fill in the multi-plastic into our cavity, and we do the packing later. And after packing, we have to make our multi-plastic to cool down, because if you did not let it cool down, then it will have the serious shrinkage or serious deformation, something like that. So we need to let it cool down. And I also want to say that even the manufacturer, the time that you will take for manufacture the encoding is already very short. But most of the time that we will still take in the cooling stage, because we need to let it cool down. It will take longer time compared with the filling and packing. And after cooling, our product will start to work patch, and we need to check the work patch is acceptable or not. If the work patch will make you cannot assembly with the different parts completely, then it means it cannot meet your criteria. Then also the fiber orientation. I said right now we have a lot of products. They want to enhance their strengths, so we put some fiber, and the fiber orientation will also affect the work patch the direction of the warp patch. So if without the CAE, what will happen? You can see that is like here's a blind here. So you don't know what will happen. So you can rely on is the dual try and error. And if the qualify is good enough, you can start to manufacture it. And if it's not good, you need to change your design again. So let's go back to this. So if you can use our software to predict, then you don't need to do the try and error for many times. Okay. So why CAE? Because CAE right now our accuracy for already good enough. Especially some as I introduced you some customers from different industry. There are a lot of well-known company. They have a lot of data here, so we already can help them to simulate by the currency way. Then it is very cost effective because you don't need to do it in a real situation, and it's also very convenient because if you have the powerful computer here, then have our software, then you can use it. So it's quite convenient. You need to invest the machine. You don't need to purchase the real material because we already have a lot of material in our data bank. So it's quite convenient and cost saving, and also save your time. Okay, so CAE, as you can see, what we can predict in our software. The flow imbalance, because if some company, if they want to manufacture a lot of products at a short time, then maybe they have the multiple cavity, and the multiple cavity, the depth between the different runner to reach the cavity, it will cause some flow imbalance. So how to make this, how to avoid this kind of situation? Maybe you can change the design. So you can draw a runner in our software, and you can choose a different material in our software. And what's more, like a short shot, the air trap actually is when the product, the end products, after manufacture the end product, there is a air trap inside. So sometimes it will also affect your structure. And where we have mentioned before, and also the same mark, especially some product we will very focus on their appearance. We want to make it smooth. Then this kind of thing we have to avoid happen. And the warp patch, okay. So why CAE? Because we use this to predict the defects, and we can try to solve it in our software. And after you see the good result in our software, you can try to use this parameter in your machine, so it can save time and cost. Okay, so the CAE workflow, and actually we have the 3 steps here. The first step is like a pre-process, because we are CAE software, so you still have to use the CAD file to import to our software. And after you importing the CAD file to our software, you need to build a runner system and cooling system. The runner system is for you to inject the milled plastic, and after the filling and packing stage, you need to make your product cool down. So we also have to build the cooling system here. And we build a cooling system here. After this, we can generate a mesh, because all of the plastic, the milled plastic, is similar to the mesh. So we need to create a mesh in our software. Not only the surface mesh, but also the solid mesh. And right now we have basically we have 3 different mesh levels. we have the BLM mesh and also hybrid mesh. And what's the difference between those mesh? This will affect the accuracy. For example, if each mesh size is almost the same, so sometimes if your product is like a circle or is a round shape, then it cannot reach perfectly. So because the mesh is like a square, so if it cannot meet the of your cavity, then it will also affect the accuracy. So we will sometimes especially the customer, they need very high accuracy. We can provide the mesh is like a hybrid mesh because it can meet the cavity perfectly. So we have to create a mesh, then run the simulation. So in second steps, we have to set the material. There are a lot of material. They have the different, maybe like a VP switch, or maybe they have they take the different time to cool down. Then like just like I mentioned, there's a thermoset, thermoplastic. You also need to consider about this material is easy to flow or not. Especially your part design is very thin, the thickness is very thin. You need to think about is easy to flow or not. So you need to set the material in the second step and set the molding process. How long will you take for cool down your product and injection speed? Because if the speed is too fast, maybe it will also have some problem here. So what's the speed of the injection? You also have to do this kind of software. So just like I mentioned, this is very similar to the real situation. When you operate the machine in reality, you also have to do all of this setting in your dashboard of the machine. So we just set what will happen in reality. So set the computation parameters, and it is the second depth. So the second depth is like analysis. So after analysis, is the last step is the post process. Like I mentioned, the process of the manufacturing, there are FPCW and FPCW, which are filling, packing, cooling, work batch. The filling, we can review it again. We have to melt our plastic pellets, and in our screw, then we move forward to inject the melt plastic our runner and cavity. So this is basically this is a filling stage. So for some customer, if they don't need to consider about their cooling or work patch, maybe they always face a problem in the filling stage. So maybe they only can check the filling result is already good enough. So this is the filling results. And the packing results, because when we inject our melt plastic into the cavity, we need to use the clamping force to pack it. And you know, after the cavity is very close to being full, then at that time the speed of your inject have to slow down. Let's imagine if you want to fill the water into a basket. At first, you can just open your faucet to fill in. Maybe you can just open 100% for it. And after it is going to feel full, then you need to turn smaller a little bit. Otherwise, it will spread or something. So it is similar to this kind of concept. So at first, the speed can be very fast, but in the end, you need to this concept is similar to the VP switch, because in the end, the cavity is already going to be filled. So you don't need to use 100% speed to fill in the melt plastic. So you can slow down to fill in your melt plastic. then make it feel full. So this is a packing result. And after packing result, we will have to make our product to cool down. But the cool down, just like I mentioned, this will take the longest time during your manufacturing. So, for example, if your most of the position already cooled down already, then if you take longer time, this will affect your manufacturing efficiency. So, for example, if you take 10 seconds, then your product is almost cooled down for maybe 98% of the position already cooled down. So do you really need to take the 5 more seconds to make it cool down completely? Maybe not, because if you take 5 more seconds, then for each product, then in the end, you will take longer time maybe than your competitor, because they always take 10 seconds to cool down their product, but you take 5 more seconds than for each one. So the cooling result, we also have to think about how long we have to cool down our product. And if we set the cooling time too short, maybe it's not having cooled down already, then you already eject it. Then it will cause a deformation or some issue like that. So we have to adjust it to meet our needs. This is a cooling result. And the warp patch result, actually warp patch is the next step of the manufacturing. And warp patch, because we need to check it will become like a smile fast or crying fast. It's like if the warp patch is like a deformation is too serious, we also have to think about maybe the fiber orientation inside. How we can set the orientation of the fiber to solve the problem, because sometimes if the part is too huge, then just like I mentioned, what will cause the warp patch, because if your part, the thickness of your part is different, then the different position, they take the different time to cool down. So after cool down, they will have the deformation. Then some part already hardened, I mean already become solid, but some part haven't. So they will pull each other. Then at that time, it will cause like a warp patch issue. So we can also check this in our software. So after you check all of this is perfect, then you can use this parameter to the real situation. And what's more, because right now we have the different material that I mentioned earlier, and also we have the like a machine response. For example, if even the same machine, maybe it's a different generation or something, so they will have the machine response. It means even you set the same bottom meter, but the result maybe will different, because maybe they have some tolerance of their screw. So even the same machine, the bottom meter, sometimes you need to set a little bit different. So this kind of things, now we are also try to make the gap between the simulation and the reality as small as we can. Just like I mentioned in the beginning, that you remember the digital twin. Actually, it's the twin. So it means in the simulation way, and the reality is the same. So we do this for our CAE workflow. Okay, so basically this is my presentation today, and now is our QA section, and I also invited our technical manager here, because he has more experience of the technical here. So if you have any question till now, you're welcome to raise. Yes.
Uh, Miss Lim said in the chat box, thank you, Stephen. I will need to leave earlier to attend to my class. I shall catch up with you later to understand more about your software and other simulation software that your company offers. Once again, thank you to sharing your expertise and experience with us and our students. Appreciate it.
No, yes, I have. Hello?
Hello, hello.
Oh, sorry. I have some connecting problem here.
Oh, no, no problems, no problems. I thought it was me.
Okay.
So far, I do have one question about fiber orientations.
Yes.
Generally, products with injection molding, are products with fibers somehow better or worse with fibers in it?
Oh, you mean uh, you mean if the fiber inside, and sometimes it will it the because it depends on what's the why you use the fiber. If you want to manage the strength of the products, can be increased, then you need to consider the orientation. Then orientation sometimes there will has a force to compensate your material. For example, if you found you manufacture the products without fiber, then it become like a smile fast. Then maybe you can use a different direction, put it inside to emulate this force in your part. So and right now, most of our experience from the fiber is like they want to manufacture the product which is emphasize the strength, not only the automotive, but also like the like some transportation towards like a ship, because they need to consider if the it's easy to crash or not. And even after the some product, if they bump into the some more hardened products, hardened things, then they need to consider if this product crash can be if it become the very small parts, then the passenger will get hurt easier. So the fiber is actually is have a variety of functions. So it depends on what kind of the demands they you want to use.
Okay,
Yes.
thank you. Uh, Mr. Daniel asked in the question in the chat box, can I know what tests will be done in CAE besides the forces of limitations?
Sorry, can you repeat again?
Can I know what tests will be done in CAE besides the force limitations?
Or the force limitation? Yeah. Okay. Maybe I invite my technical manager to answer this question.
Yeah, hello, good morning, everyone. I'm Edward from Oplex 3D.
Hello.
And I think to answer that, where is your PPT? I think to answer that one, I can link with the PPT from Mr. Lin. Can you see this one?
Yeah. Can you see my slide now?
Yes, we can.
Yeah, maybe play. Yeah, so basically for CAE software, maybe we need to understand from this page is there are two big category in here that we addressed. So for the one that you mentioned that about the force limit and so on, that one I think belongs more up to the structural CAE software, which is in the area of like ANSYS, Abacus, Altair, LS Dyna, and so on. But for our part, we are also CAE software, but the thing is different. For us is we test the manufacturing process instead of the structural thing, like the force, the whether the part cracks or not. That one belongs to the other zone. But for us, it's the manufacturing. So what we are doing is we do the simulation for injection molding. So it means how the process goes on. Okay, so for example, I think like let's say the simple one is like when you want to see the filling animation. Like, okay, I have the part, I put the gate in one location, and then I inject it, and then I want to know like whether the filling will have short, or the filling will go smoothly, or maybe how the filling pattern, like maybe we'll have a wet line because there are like split filling pattern and converts again, something like that. So those kind of things that what we do for our test. I mean for the testing. It means for manufacturing stuffs. Okay, so you can see what like I mentioned, filling pattern, maybe the pressure distribution, pressure drop, temperature distribution, and maybe also warpage. So like how the part will bend because of the shrinkage, something like that. Volumetric shrinkage, or maybe cooling efficiency of your cooling channel, something like that. So CAE software can do many things, but the thing is we need to understand in which area. For us, is the manufacturing for plastic injection molding process. But for others, of course, there are some other like structural analysis or thermal analysis or electric analysis and so on.
All right. Dr. Lee asks, how often is the data updated in the data bank?
Okay, for the data bank, actually we update it every year. So because every year we will release the new version. So usually our data bank, like for example in this case is machine data bank or the material data bank. Yeah, each year we will update it. So there could be like another 100 or maybe 50 new materials in the new version and so on.
All right. Mr. Ong asks, using simulation software to help predict defects is great. However, different plastics from different manufacturers have different properties. How does the simulation software can predict the defects accurately?
Okay, so for that one, if you notice, like in the injection molding, we have 4 big key factors, right? Number 1 is part, which is the product design, and then I think you have it. Or maybe I will just mention it. Anyway, number 1 is part design. Number 2 is the mold design, which is contain the runner, the gate. Oh yeah, that one. Yes, this one. So and product design, mold design, and then material selection, which is the material that you use, and also machine and process settings. So to make the CAE software prediction accurate, of course, we need to pay attention to these 4 key factors. As long as those 4 key factors are collected and are clear, and then when we apply it in the simulation, we input it in the simulation, everything is matched, everything is correct as the actual ones. So we can expect that the simulation accuracy will be high. That's the thing. So even if you have different materials, like you use material A, B, C with different properties, no worries. As long as you can select that material in the simulation, it means that you can find it in the data bank. Or even if you cannot find it, actually we can do substitute material, or maybe we can do the material testing, something like that, and then we get the material file to run the simulation, then everything is good. So it means we will also consider those different properties while we are running the simulation.
There are some follow-up questions. Do injection molding machine, the model and the size affect the simulation results?
Okay, yes, the answer is yes, because for example, but about which parameters of the machine will affect most to the simulation, we have some parameters. For example, I will say the most significant one is screw size. Okay, the screw size, because you need to input it. Let's say you use the screw size 30 millimeter or maybe 60 millimeter, and then you run using simulation, right? When you run the simulation and then you refer to that machine, the screw size will affect like what is your flow rate. Because for example, you set the setting like the speed is 10 millimeter per second, let's say. but that 10 millimeter per second will be converted into the flow rate. So that's why one of the significant factor in there is screw diameter. That's why when you select different machines, it can affect like how the results will be. Okay, that's the basic fundamental thing. The other thing is about the time response. So actually, we also have one module, we call it machine characterization. That machine characterization actually try to characterize your personal machine. I mean, like your real individual machine, because we know like one machine will behave differently from the other machine. Okay, because maybe, for example, this machine is already too old, or maybe this machine is brand new, or maybe the manufacturer like tune up some, did some adjustment in the response, like the speed response, the pressure response. So it will also affect your final result. So that's why this is also the other factor that may affect the simulation result. So when you select different machines in Modex 3D, and especially if you include also that characterized machine, actually, yeah, it will behave differently.
All right. One more question from Mr. Ong. What is the most important parameters in the simulation?
The most important parameters, I think, all these four are integrated. Because if you, for example, you miss one, then there is a chance or a door for it to become inaccurate, right? So that's why to talk about like the most important, I think we cannot like really break it down. In the end is therefore are integrated. So please make sure we also have the correct one and then the good one. But one thing for sure, maybe in the beginning, because we know when we start from scratch, actually some people will start from the part design, right? So most of our users actually will start from the part design. So maybe in other words, some people maybe will say the part design is the most important one. Okay, you start from the part design and then you do the trial and error before finally you decide the material, you decide the machine that you will use, or you decide the final process settings. Yeah, you can do it. But again, like actually all these four factors will affect one another, that will finally become your final recipe when you choose to manufacture this plastic product.
All right. Thank you. Does anyone else have any other questions? How from T? Sorry. Thank you very much, Stephen. May I know if this software also includes data for plastic blends? What is the indicative cost?
Sorry, can you say plastic blends or plastic
Yes.
what?
Data bank.
Oh, for the plastic blends, yeah, we have polymer blends also in our data bank. Okay, so but again, you need to cross check again whether your exact material is there or not, because for some special material, I know that we are still developing it in our data bank, so maybe some of them are still not ready yet or available in our data bank. But no worries, like we can also do the material testing, and then we keep developing it, and we keep adding the materials into our data bank. And you want to ask about the cost? What do you mean?
What is the indicative cost?
Oh, indicative. Oh, okay. I think for that one, no, we don't go to that direction. Indicative cost. The thing for the material in here, did you share? You share that you have material, right? Yeah, but basically in our material, actually, if you see when you use the software, later you will see the parameters inside there. So talking about the material is only the properties that we need, like maybe viscosity, PVT, and so on.
Yeah, because about the cost, it depends on what kind of the material testing that you want to take. For example, if you just like I will mention, maybe you just want to check the PVT or kinetics. So the different topic, different feature that we want to check will also affect the cost, because some of the customer, then maybe they use for example, even like a thermostat, the thermoplastic, they already have the different thing need to check. So for some of them, maybe they already have the existing data, and we just combine the data from our lab with their data, something like that. So for the cost of the material testing, right now we just customize by the customer needs. Yeah.
Okay. Mr. Daniel asks, how do engineers know the product is safe to use by referring to the CAE software?
Because as you can see the result of our software. So at that time, we won't set this because just like I mentioned that even the same machine, they still have the some tolerance, some difference between the same machine. So of course sometimes there was still some gap between the simulation and the reality. Then so that's why we just give the direction. But if let's say if the customer can provide as much data as they can, so of course this can increase the accuracy. But because most of time the customer they just give us some insufficient data. So of course what kind of the data that we gather, then we can just rely on this data to generate the result. So we just give maybe sometimes we give the direction from which side, and then you can move to. And some of the customer, maybe they already do a try and error for many times, and they just have some insufficient. They just have some want to do what, maybe just do one more time, or to check if they change this parameter, what will happen. So if based on this kind of scenario, then we can just help them to, at least they don't need to go to the wrong direction, because just like I said, if they choose the material will also affect the result. So so we can under this kind of situation, we can give them the direction. Yes.
All right. Another question. Which molding defect is the most difficult defect to remove or minimize?
Okay, let's move to these slides. I would say because the warp patch is the most is the difficult things that we can remove, because there are a lot of factors will affect the product to be warp patch. So sometimes it's not only one factor to affect this result. So just like I mentioned, when the plastic, you melt it, you heat it up, and you melt it, and when it becomes solid, of course the volume will change, right? So after the deformation, if the different parts have the deformation, then you also have to consider about, like for example, the part design. If you put the gap in the wrong position, and can you just move the gap to the position that can make the flow become balanced or more even? So you need to think about from the part design, mold design, till the material selection. All the factors will affect this, because just like I mentioned, what's the main reason cause the warp patch? Because the different parts, they take the different time to cool down. Then after you cooling down, of course there were deformation. Then deformation at different time, they will pull each other, so it will cause a warp patch. So how to solve the problem? Actually, you need to for example, you maybe at first you can just rely on your experience, only change the one factor. Then because you cannot change a lot of factors at the same time, otherwise you won't know which one will affect. But of course, you also can do that if you don't know how to start to solve this warpage issue, maybe you can just try to adjust the parameter, a lot of parameters at the same time, and see what will happen. So what I want to say is there are too many factors will affect the warpage. So if your question is like what's the most difficult to remove, our answer is warpage.
All right.
Right.
Mr. Daniel asks, will they still do the hardness test or any test to know the strength of the material, just like in automotive industry that performs AEC, Asian and CAP to know the safety rating?
Oh, do you mean that how to check the? Okay, sorry.
Oh yeah, I think I would like to answer that one. So a hardness test and so on to make sure the part is strong enough. Of course, for automotive company, they will do it from their plastic product. But again, for that one, it's not in our simulation site. Because for our site, we do not go to that direction. We only do the manufacturing process simulation. And I think this page. But the thing that can help them for the next structural CAE simulation also comes from our side. Because, for example, in this page, it's very clear that our role is on the left side. We do the manufacturing process in the simulation, right? And then from us, we induce the problem, or if there are any problems, or maybe induce some process-induced properties. For example, because your material has a fiber, and then you run the simulation of the manufacturing process in our software, you can get the fiber orientation for your plastic product. And then this data is required or needed to determine your part strength in the next CAE simulation. The next the next CAE simulation is for structural analysis, the one that you mentioned for checking the part strength, maybe whether the part cracked or not. Okay, so by running the simulation in the Moldexity first, we can give them the input. It means the input for the next stage. Okay, so again, of course, they will do it. So that's why actually our user, especially like for example in the automotive, what they do is usually they will have two software at least. Okay, number one is the Moldexity to simulate the manufacturing process and then get the process-induced properties. Okay, for example, maybe fiber orientation or maybe like weaker strength because you have wet line. Okay, and then this result will be passed down to the structural analysis, which is maybe they buy ANSYS or they buy Abacus or LS Dyna and so on. And the thing is, Moldexity has the bridge to connect the bridge to connect them, which is we have one tool in our software that can output the results. So it means our result will be continued to the structural analysis, and then in the structural analysis software they just need to import that data and then continue to do the structural analysis and so on. So yeah, they will do it, but not in our part. It will be like the next stage or the next part, but they take the data from us. That's the scenario.
All right. Leo Cheng says, hi, thanks for your sharing. I want to ask if we found the weld line in the simulation, how do we do? Can it be removed?
Okay, so good questions for the weld line. Maybe open the page of the weld. Okay, for the weld line, most of what I see in my experience, actually most of the solution to really like eliminate the weld line is to change the gate location. Okay, or maybe if you use hot runner, you need to use the valve gate. Okay, maybe you open it sequentially, so there will be no wet line if you have more than one gate. Okay, so those two, change the gate location. Maybe you don't want the wet line to be there. You change the gate locations to make it maybe like going somewhere else. And then, or maybe number 2 is you use the hot runner sequential valve gate, or you also can change the filling pattern by changing the part design. So you purposely change the melt from direction or the melt from pattern, so the wet line will move to another section which is maybe not important or not critical, okay, or maybe at the section which is hidden, so you don't see it, something like that. So those 3 things usually will be the wet line solution to really eliminate it. Okay, and then the other thing is you can also try to play with the temperature. So it means what? Actually, the temperature, the wet line stays there. Okay, the location will be there, but the visibility will be like less visible. It could also be disappear. The thing is you need to play with the temperature. So for example, when the melt meets together, the 2 melts meet together at that location, they meet at high temperature, so they can like fuse together better, something like that. So they can like mix together better, and so that's why the wet line maybe will be less visible, or maybe can be also really like disappear. Okay, and it can also help to strengthen the part. So by doing that one, by increasing the temperature locally at that location, so because it can mix or merge like very well, so that's the bonding is very well, so that's why the part strength will not be reduced so much. Okay, those the thing to eliminate the wet line. Again, like to really change the position, you need to change like the gate design, hot runner, maybe use the hot runner sequential, or maybe change the part thickness. But if you are fine, the wet line still there, but you really want to increase the part strength, or maybe try to make it less visible, then you can play with the temperature.
Okay. Mr. Kai asks, when dealing with the cooling process, can it be simulated accurately when considering active and passive cooling?
For the cooling analysis, like we mentioned, about accurate or not accurate, it comes from also the input that we give. Okay, and actually our cooling solver, we also have the 3D coolant CFD. So it means if you also want to check more detail about the cooling effect to your system while you are running the simulation, you can also turn on that 3D cooling CFD. So it will add more considerations while you are running the simulation. Okay, like for example, it will also include the roughness of your pipe, something like that, and then you maybe you also include like how the flow stream in your simulation, something like that, to see whether the cooling like stuck, maybe there is a vortex in there and so on. So you can include that when you run the simulation to increase the accuracy. Okay, and then about the setting itself, like how the way you set it, yeah, we have the setting user interface, so it depends on how you set that up. The thing that you can set are like, for example, you can set the temperature, you can set the flow rate of your coolant, I mean, and you can also set the type of the coolant. So all those the things that you can set about the cooling system. Okay, so as long as those things are correct, and then just like as the reality, so basically we can expect that the accuracy will be high.
All right.
Okay.
Mr. Ong asks, are plastic simulation software popular in Malaysia?
Sorry, could you repeat again?
Are plastic simulation software popular in Malaysia?
Oh.
Okay, I think interesting question. So about popular or not popular, I think it as long as there are many, I mean, like plastic industries in Malaysia, so basically we can say they are popular. But maybe the thing that gets stuck in the, how to say, in the market, I mean, in the some people out there, what they think about simulation is always they think about structural analysis. Okay, so what they think is always about like ANSYS or always about like Abacus, LS Dyna to check their part strength. Okay, so usually those things will overshadow the manufacturing software, which is, for example, in this is Moldex 3D. But in terms of the need is there, and the need is big. Why? Because for this thing, as you can see in this bridge, I mean in this schematic, you can see that actually when you have the plastic product, and then you start directly only like, okay, you design the plastic product in the CAD software, and then you do the CAE software only for part strength, something like that, actually it's not enough. Why? Because, for example, in this figure, it's very clear that actually you miss some data. Okay, you miss the process-induced properties from your plastic products because you do not run the simulation for your manufacturing process. So that's why if you jump directly like from CAD to CAE and then your CAE is only structure analysis, actually is not comprehensive. For example, maybe when you run the analysis in ANSYS, for example, you run the crack test. Maybe you don't see that the part cracked, but in reality it cracks. The reason is why? The reason is because maybe you neglect the portion which is, for example, the fiber orientation. You don't run the fiber orientation simulation in ANSYS. You need Moldex 3D. So that's why you need to run the manufacturing process in CAE software. In this side is Moldex 3D. You get the fiber orientation. And then when you do the crack test, we also consider the fiber orientation, or maybe we also consider the well line. And then maybe when you rerun it in ANSYS, the crack test, and then you find your part actually cracks. Okay. So whether it's popular or not, again, it depends on the market. But like I mentioned, the market nowadays, they are still stuck with the thought that, oh, CAE software is only ANSYS. The CAE software is only like doing the part strength. Okay, but actually it's not only like that. And yes, the thing is, the need of Moldex 3D is very big because, again, if you see the plastic product, there are many, right? And plastic product only not cover automobile, but it also cover some other stuffs, is consumer goods or even your daily life stuffs. A watch, plastic watch, cover the printer and so on. So actually, I can say personally it should be popular. But the thing is, the way how they interpret the CAE software is only ANSYS. I mean, it's only like structure analysis, or actually it's manufacturing. And yeah, the need is big there. Okay, yeah, I think that's the answer.
Okay. A follow-up. Any big company in Malaysia using plastic simulation software to help in their production?
The company in Malaysia?
Yeah.
Because some company that is like even we have the collaboration with a very big company. As you can see these slides, there's well known, and because some of the technology company they have the like confidential, so maybe we cannot just mention who's the company that we cover with now. But for the industry, we already cover with some big companies that manufacture like IC packaging. So in the past, maybe when we talk about the injection molding, the first thing coming to our mind, we will always think about like our daily stuff or something. Is like maybe we won't think about this way related to the technology company, but actually our software can simulate the underflow. Just like I mentioned, the compression molding, transfer molding, this kind of flow front can be simulated in our software. So when some IC packaging company, even in Taiwan, we have a lot of well-known IC packaging company. They all, I mean, they will have this kind of demands for the simulation. So so what I want to emphasize here is maybe we can think about another industries, not only for the automotive industry or something. Yes.
Oh, maybe I would like to add about the big name of the company. Actually, this page is also a teaser, right? If you notice, maybe some company like in Malaysia that belongs to this big company, yeah, it could be their chance that company is now using Moldex 3D. Okay, so for example, maybe I stated like Udo. I know that Udo are using it because I also visited them. But the others, yeah, you can take a look. Actually, there could be a chance and opportunity if you have these skills. I mean, to use the Moldex 3D software. Basically, these all the targets that maybe you can work on later in the future. So, and whether they have the branch office maybe or the branch factories in Malaysia, then it is good news because there is a chance that later in the Malaysia for the Malaysia side, they also will implement and then use the software as well. Okay, so yeah, this is maybe just some of the list, and you can see whether this company exists in the Malaysia, and there is a chance that they are also using it.
Oh, all right. There's a question here. How to determine the volume requirement for a product? Can it be done in the simulation?
The volume for that part actually usually will be determined during the part design. Okay, so about the volume again, like when you do the part design, of course there could be some considerations like aesthetic or maybe the functionality or maybe the structural, maybe they add ribs, blah blah blah, and then it will integrate all compiled together and then become the part volume, something like that. And so that's why actually our software is not directly help that one because that one will be in the CAD stage. But what we can do is, for example, you already decide the volume because you decide the design, right? The part design. The thing is whether this design can be manufactured or not. That's our role. So okay, so or maybe because of this design, maybe like let's say your part is too thick. Okay, of course your part is too thick. Maybe it will also increase your volume, right? And then you inject the simulation. I mean, you do the injection. So when you do the injection, because the part is so thick, you will suffer maybe shrinkage, sink mark, okay, something like that. So, and then you need to revise your design. You need to cut the thickness, make it thinner, or maybe make it like a ribs instead of like thick section, and then it will reduce your volume. So saying that whether we can help to determine the volume or not, yes, but maybe it is more like indirectly. It means like you need to check it after you get the results. You check whether the design now is able to be manufactured or not, or okay, it's manufactured, but you will face many problems. Okay, so you need to revise it. You need to revise. So yeah, we can help, but again, like actually in injection molding, maybe we don't talk more about the volume. It's more like how is your thickness, how is your like features. Maybe you have ribs or not, something like that. It's not like what is the volume, something like that. Yeah, usually we don't. But again, we can help also to verify your CAD design, your part design, just like illustrated in this page.
All right. Another question here. Since injection molding always compared with 3D printing, will you guys consider 3D printing field as well?
Okay, good question. So as per my understanding, actually our RD now is developing towards that direction. So there could be in the future, maybe we also will develop 3D printing simulation, something like that. Yeah, because actually now we already have some advanced technologies like for IC package, we have what we call like dispensing, something like that. So maybe we will integrate some, we use some recipe from that one to become the 3D printing. Yeah, there is a chance. So in the future, there could be another branch of Moldex 3D, how to say, software application and going to the 3D printing.
Okay. Does anyone else have any other questions? Now is the time to ask. Uh, Any other questions? Okay, here's one. In injection molding industries, the product will be categorized in first grade, second grade, and so on. Wait, let me. In injection molding industries, the products be categorized in like a first grade or second grade, and so on? Like, is there a grading system?
Oh, I think about the grading system, maybe, yeah, there could be, it depends on like factory by factory, but there could be also talking about the material properties, because what I know in the reality, usually some of them maybe also implement like some recycled material, something like that. So it could be the grade is already like lower than the virgin material, like the pure, the original material, something like that. Yeah, there could be they also grading it by that system. Yeah, again, it depends on the factory by factory.
All right. Any other questions? If there are no further questions, can I ask everyone to turn on their cameras, because our organizer wants to take a screenshot per se.